You would probably assume that athletes are faster when they race someone versus when they're just running by themselves in a sprinting workout. But is that actually true? This is a research question that my coworkers and I wanted to answer at TC Boost Sports Performance. And in this video, I'm going to take you through how I developed this internal case study to answer the question, are athletes faster when they race, or what is the effect of racing on sprint times? So I'll take you through the process of the question, the intro, the methods, results, conclusion, and practical applications in this video, and explain how you can conduct one of these internal studies yourself. First, the intro, the rationale, and the research question. Our job as coaches, specifically at TC Boost Sports Performance, is to get our athletes faster. So how in training can we get our athletes to compete and consequently draw more effort out of them and hopefully faster sprint times? So everyone loves competing. No one likes losing. So racing is a really awesome way to get our athletes to run faster and also learn how to compete a little bit more. So effort is way up, and consequently when athletes are trying super hard, technique might go down. So it's this kind of give and take, and we wanted to know, are our athletes running faster, sprinting faster when they are racing someone else, regardless of if their technique might slip just because the effort is so high? Or are the times not really that different, so we should save the good technique and save the amount of reps and just get really high quality with good technique and good times if sprinting isn't actually faster itself? Next, the methods. What are we actually going to do and how are we going to answer this question? And I'm going to tie in the stats also, because if you know what stat tests you are going to need and use, it's consequently going to affect how you collect and organize and store your data. So the methods, I'm going to need the same athletes to run 2 sprints by themselves. I'm going to need the athletes to run 2 sprints racing someone else. And then I'm going to run a paired samples t-test. So t-test is just the difference between 2 groups, and the paired samples means that group 1 numbers and group 2 numbers are related. They are connected in some way, shape, or form. So it's the same athlete by themselves and the same athlete when they are racing someone else. So those numbers are already pretty close. That's why it has to be a paired samples t-test. And I didn't want the effect of racing someone, if it is faster, to then warm them up or get their body, their nervous system in a better state to then run by themselves. So I knew that I wanted to do this alternating race by themselves, and consequently, sometimes half the athletes, they run by themselves first, and half the athletes, they race someone first. So it's alternating which one they start, so there's no kind of warm-up effect. And then consequently, having 2 of each, I would take the average of their 2 sprint times by themselves and the average of their 2 sprint times racing, just to kind of take away just having one really good run by taking the average of 2. And second, a very important factor with the methods is that I did not tell the athletes any of their times until after we were done with the workout, because I didn't want a sprint time of by themselves for them to know that it was slower than when they were racing someone else, and then consequently they would try harder the next time. So I wanted it to be as unbiased as possible. For sprints, I'll tell you if you're by yourself, or I'll tell you if you're racing. I'm not going to tell you your times, and then it's going to be in this alternating order. I had 22 athletes. I had 8 youth, so 9 to 11. I had 11 JV, so 12 to 14. And I had 3 varsity, 15 to 18. And the race I wanted to use was the 5:15. So the athletes start on yard 0. The first laser is 5 yards away. The second laser is 15 yards away. So a 15-yard sprint, 10 yards of the actual laser. And this was consistent because they had a starting line to where I could say go every time. Next, the results, the numbers of everything. So get ready for all these numbers. The solo mean, the solo average, so the solos when they ran by themselves, 1.683 seconds. The race mean, the race average was 1.642 seconds, with the mean difference being 0.0414. with a p-value of less than 0.001. So p-value, simply put, is what are the odds that it was not chance? So what are the odds that the difference was actually real? So there's a 0.1% chance that the difference between the two groups was just random. So 99.9% sure that there was an actual difference. So there was a difference, but then to evaluate how big that actually was, I used Cohen's effect size. So effect size is just how big was the effect relative to was there actually an effect. An effect size of 0.8 is big, so this was a big effect, and there was a 99.9% chance that it was a real effect as well. Conclusion, so what does this mean? Knowing that they're 0.04 faster, they're 2.5% faster, that's a big difference, and it is a real difference. Athletes are 2.5% faster when they race someone else versus when they just sprint by themselves. And there are some limitations and there are some practical implications. So limitations is that I did have a relatively young group of athletes, group of subjects. Only 3 of the 22 being in high school with everyone else being under high school. So there could simply be this effect of they don't truly know how to run hard by themselves. They don't know how to go 100% without some sort of external motivation. So these results might be a little different if it was just high schoolers, or maybe if there was college kids included as well. So that is one potential limitation. Second, this was just one type of sprint or type of race. This could be a little different if it was a 180 cut, so a test of agility, or a pro shuttle. But overall, knowing that statistically speaking, athletes run faster, knowing just anecdotally that athletes enjoy it more, they just have fun racing and competing, and knowing that with a lot of groups, with big groups, we're gonna take a lot of rest anyways. So it is worth maybe getting a few more reps in because you're going twice as many athletes or 3 times as many athletes. It's worth because engagement is up, and it's worth because the actual time of the sprint is faster. Now, technique might not be the best, but if you were to pair this in, let's do a majority of our reps solo, and then we'll finish with 2 races. So we have a ton of high quality technique-wise sprints, and then we put it all together with races, letting it eat, just going, competing, and having a good time. So that is how I structured this internal case study to answer the question of what is the effect of racing on sprint times. That's how I organized it. That's how I went through the data, the practical applications, and that's what I found. And hopefully, explaining this thought process, you can work through your own questions and do your own sports science. So happy sports sciencing.